Okay, let us define this more formally. By NAB, x and yn, we denote the number of times the pair AB occurs in the sequence of pairs x1, y1, x2, y2 until xn, yn. And now if we want to denote the set of jointly epsilon letter typical sequences, we denote them by this set here, and these are all sequences x and yn such that 1 over n of NAB of x and yn minus the joint probability of AB is less or equal times epsilon times the joint probability of A and B for all A and B in x and y. We have the following nice property. If x and yn is jointly typical, then xn is typical concerning px, where x is the marginal of xy, and yn is also typical. So what you immediately see is that jointly typicality is a special case of the usual typicality, since we can view the word xy as one random variable z. So suppose that x tilde n and y tilde n are output by the statistical independent source px and py, then we have the following property. We have look at the theorem, we get the theorem here that the probability of x tilde n, y tilde n, that these are typical, this is approximately 2 to the minus n of the mutual information. Let's see the idea of the proof. Therefore, we write the probability of x tilde n, y tilde n, that they are jointly typical. We can write them as a sum over all typical sequences of pxn, xn, and py of yn. We can do this because they are independent. Now, all the probabilities here, we know that we now know that x tilde n is also typical, so we can estimate it by 2 to the minus n, 1 minus epsilon of h of x. And we know that y tilde n is also typical, therefore we can estimate it by 2 to the minus n, 1 minus epsilon h of y. So we know that this here is always constant, so it's always the same. We can estimate by the same value. And therefore we can estimate this by the cardinality of the typical sets. And here we know we consider xy as a random variable z and can use our estimate for the usual typical letter typical sets. And so we can estimate this by 2 to the n 1 plus epsilon h of xy. And if we now put all this here together, then we exactly get the mutual information here. It works also the other way around. We just have to estimate this the other way around, and therefore we get the desired result.